Alright, today I'll be demoing um, a library I wrote called Gyptis. It's used for generating and viewing Vega.js plots. So here in Emacs, I've loaded the Gyptis usage example, which you can find in the repo here. So I'm just going to eval each form one by one, and the results will be printed next to the form in green. So here's an example of that happening. 1 plus 2 is 3. Good, math still works. So let's just load in the Gyptis libraries. I've also prepared some data that we'll define, and now let's make a bar chart. So this opens up a new browser tab, and it plots data. So that's cool. This dodged bar function actually returns pure data. It's a pure function, so it just returns data. It returns a hash map representation of the Vega JSON that goes into making this plot. And then the plot function just sends that data into the browser for Vega to render into a canvas element. Stacked bar is similar to dodged bar, but it positions the bars on top of each other. And since these functions just return data, it's really easy to modify the Vega specification. So we can add things like an axis label and title, and we get what we expect. Vega also supports mouse interactions, so you can add a hover interaction here. And so now when I put my mouse over the bars, they turn red. Gyptis also supports trellis plots with this facet global function. So now instead of plotting the bars on top of each other, they're plotted in completely separate plots. And so this makes it really useful for looking at different subsets of your data. Gyptis works on Java util dates. So here's a quadratic function that has stroke A, and here's a linear function that has stroke B. Let's make a line plot. And you see that one of the colors is a quadratic function and the other plot is a line, and the timescale is rendered in a human-friendly form. Alright, so Vega has a lot of specialized syntax to help you calculate aggregations and statistics. Gyptis allows you to avoid all of that. Instead, Gyptis is designed to interop very easily with JDBC. So this allows you to define all of your data munging and transformations in SQL. And I think that has a lot of benefits. Namely, you get to have the readability of SQL, and it's a lot easier now to access your data, which is probably sitting behind RDBMS anyway. So here I'm loading a few data tables, a few CSV files into tables in H2. So the unemployment table just describes it describes the unemployment rate for each numerical county ID, and there's a FIPS codes table that relates that numerical ID to some human names. So now we're going to visualize some unemployment statistics. Here I'm just querying the top 20 counties by unemployment rate. We'll make a bar chart out of that and then give it a title. Cool. So this 6025 here has a 30% unemployment rate. So that's not very useful because I don't know what 6025 is. So we can make a new query here that joins those IDs to the county name. And then we'll plot that. And we can see that that was Imperial County in California. Okay, so the last example I have is map making. So this US10M table contains GeoJSON data for the borders of every county. So this query returns a table where each row has a GeoJSON definition and the unemployment rate for a county. I think there are thousands of counties in the US, so I'm just going to print out one of them. Cool. Yeah, so you can see under the geopath key, there's a GeoJSON hash map, and then under the fill key, there's the unemployment rate. So we'll feed that data into the choropleth function, give it a nice title, and then plot it. And now we have a map. And this must be Imperial County, this really dark red spot here.